Let's take a look at the pattern of how scale factor affects changes in perimeter and area. By now, you should have been working on assignment 3.1, where you had these three pairs of similar shapes, and you were looking to find the scale factor, perimeter, and areas of each of them. And as you were going through them, and what we're going to do in this video is explore how does the scale factor affect how much the perimeter and area increase by. All right, let's start by looking at just the perimeter. I'm going to start up here looking at our two rectangles. First, we said the scale factor was 2. Remember, scale factor is how many times bigger the sides are getting. Well, all the sides were multiplied by 2. 3 times 2 equals 6, so the scale factor is 2. How does that compare to how much the perimeter increased by? The perimeter was 8, now it's 16. 8 times what equals 16? The perimeter got 2 times bigger. Down here with our squares, we said the scale factor was 3. All the sides were being multiplied by 3. How does that relate to how much bigger the perimeter got? The perimeter was 8. Now it's 24. 8 times 3 equals 24. How about our triangles? When the scale factor was 4, how much bigger did the perimeter get? 6 times what equals 24? The perimeter down here got 4 times bigger. Y'all, I'm noticing an easy pattern right here. When the scale factor was 2, the perimeter increased by 2 times. When the scale factor was 3, the perimeter increased by 3 times. And when the scale factor was 4, the perimeter increased 4 times. That's a really important pattern that we're going to have to use. So let me write it down so we can keep track of our learning. The perimeter increases by the same amount as the scale factor. All right, we're also going to have to find the pattern of how scale factor affects area. So let's take a closer look at that. Back up to our rectangles. When the scale factor was 2, how much bigger did the area get? The area was 3, and it grew into 12. 3 times what equals 12? The area got 4 times bigger. Down here, the area was 4, then it grew to an area of 36. How many times bigger did that area get? 4 times 9 equals 36. And how about our triangles? The area was 1, and it grew to be 16. So how many times bigger did the area of the triangle increase by? 1 times 16 equals 16. You might be noticing a pattern right now, but if not, let me go ahead and organize those numbers into this table. When the scale factor was 2, the area increased by 4 times. When the scale factor was 3, the area increased by 9 times. And when the scale factor was 4, the area increased by 16 times. I want you to pause the video right here. See if you can find the pattern of how scale factor affects how much the area increases by. You might notice that if you take the scale factor and you multiply it by itself, so for example, 2 times 2, you'll find how much the area increases by. 3 times 3 equals 9. Scale factor of 4, well, 4 times 4 equals 16. There's a really important way in math that we write equations like this, where you multiply a number by itself. 2 times 2 is the same as saying 2 to the power of 2 with an exponent. I can say 2 to the power of 2. I can say 2 to the second power. You're also going to hear me say 2 squared. 3 times 3 is the same as 3 squared. 4 times 4 is the same as 4 squared. So the pattern that I'm noticing is whatever the scale factor is, if I square that number, then I know how much the area increases by. Let me write that down so that we can practice using that pattern. The area increases by the scale factor squared to the second power. In assignment 3.2, you're going to have to use both of those patterns. We know how much the perimeter increases by. We know how much the area increases by. Use the scale factor and the patterns that we just explored to find the missing perimeters and areas on your assignment.